All right, naming ionic substances with transition metals, or obviously writing formulas too. So let's do an example, and we'll use our document from today to sort of get us started. So we're going to pull that up as well, and I'm going to close this one. And that was actually produced yesterday. I saw that one person actually turned it in already. So this is from the week 8, day 3. Okay, that one right there is the one that we're going to open up. And so I can pull one off of this and I will put it in the notes then. All right, we're going to start with, let's pick one here. Let's do tin 2 oxide. Tin 2 oxide. So I'm going to write that one down, and we're going to figure out the formula for that one. Formulas, I think, are pretty easy. So we'll do our first example, tin. Now remember, the Roman numerals are in parentheses 2, and then we have the oxide. All right, the first thing we got to do is we got to look at, okay, what are our two metals, or what are our two substances? It's ionic, so we have a metal, and then we have a non-metal, which is oxygen. So we know we have those things there. So we go to our periodic table, and we look for tin. I always have trouble finding tin. There it is. It's SN, which is bizarre. And there's two versions. There's an SN2 and there's an SN4. Well, obviously it tells me it's a 2, so I know that it's a +2 ion. So I'm going to put SN down, and I know that it's +2. And then my oxygen is always this, non-metals, they never change. They're always what they are, O, and this is O2, -2. Okay, so this one's pretty easy, actually. So I wrote them both down, and I just took that right off that chart there. So tin 2 told me that it's a +2, and I looked up the periodic table. And so those are my charges. Well, they're already balanced out, so 1 and 1 is all I need. So my actual formula is SnO. But what if it was tin 4 oxide? So tin 4, Roman numeral 4, oxide. Well, that's going to be a little bit different. That I'm going to have the Sn, and I know that it's a +4. I know that oxygen is only a -2. All right, so put in the chat, what do I have to do to balance this? Again, this one is done. How do I finish this one up? Okay, and Abby has mentioned it, and Kendall has mentioned it, and Megan has mentioned it. Yeah, we're going to need another oxygen. So I multiply it by 2. That changes it to -4. And now my new formula is SnO2. Notice that this does not look, like I said, a lot of people think that 4 means a subscript. It does not mean that. Those Roman numerals are charges. Those are charges. So we just did formulas, by the way. Now let's reverse it. So let's go to the reversal of this up here. And the reversal, let's go to our problem. Write the names for the following transition metals and their compounds. So let's do the F. Let's do PbNO3 2. I'm going to write that one down. Flip my paper. So I'm going to do F. And PbNO3. And there's a 2 there. Okay, so I have that. All right, so there we go. Now we have to figure out the name of this. Well, we know this is lead, so that's easy. We have a polyatomic ion. Let's see what the name of it is. We go to that periodic table that we have, NO3. We look for that, and that's nitrate. Pretty common polyatomic ion. So we have lead, nitrate. But because lead is transition, it's a transition metal, it means it could have more than one charge. Well, the nitrate I know, there's 2 of them. Okay, so I can pick off my nitrate charge right away by looking on here. Since there's two of them, each one has a negative. Okay, cool. I know that. So 2, and each one of these is the -1. That means my overall charge on my nitrate is a -2. That means my lead has got to be a +2. Well, that means I have lead 2 nitrate. So that is the correct, that should be correct. And let's see if lead has that. PB, yes, there's a 2 and there's a 4. So I'm using the 2 in this case to get that lead 2 nitrate. If you want me to do another one, tell me in the chat and I'll do one more. By the way, that was F on our problem sheet. If you want me to do one more, I'll do one more. And then we have potluck in here, I see. I'll do one more. Sweet. You want me to do formula or name? Okay, name. All right, so I've been requested to do name. Let's do this one. This is kind of weird. HGCR207, which is G. HGCR207. There you go. And let's see what that is. All right. Well, I know the metal in this case is mercury. You can pick that off the periodic table. And this looks like a chromate, but I'll double check. Could be something different. Who knows? CR, I look up here, CR, where's that CR stuff at? Oh, there it is. Dichromate. So it's CR207. It's buried in the left side there. It's got a -2 charge. So -2 charge on that. And it's dichromate. So this is dichromate. Dichromate is its name. Polyatomic. Has a -2 charge. There's only one mercury here. That means the mercury's got to be +2. And there we go. Mercury 2 dichromate is the answer for that one on G. And if I look on here, mercury is either +1 or +2. So we're obviously using the +2 on that one. So that's how you do that. So naming transition metals, again, Roman numerals always indicate the charge. We'll put that on our notes in the front here. So Roman numerals indicate charge. There you go. And that's the key trick with that. Tyler DeWitt also has videos on naming transition metals as well. All the naming stuff, you can use him also. I'm going to stop that recording.